Hello everyone and welcome back to another video, and today we'll be doing part 3 of how to ace that SAT math section. And today we'll be looking at two main topics: algebraic transformations and function notation. So without any further ado, let's get started. The first thing that we have are algebraic transformations, and so let's talk about a transformation first of all. So a transformation is just a change in the function and how it looks. So for example, if we had a graph that looks something like this, and we wanted to move it to the right, we would simply do a horizontal shift. If we wanted to move it up, we'd do a vertical shift. And if we wanted to make it closer to the y-axis, we'd do a vertical stretch. And if we wanted to be away from the y-axis, we'd use a vertical compression. And with the horizontal stretch, we would have it closer to the x-axis. And with a horizontal compression, we have it further away from the x-axis. So let me show you what I mean. So this is the main equation for transformations. And let's just go straight into these. So we only need to know two of these transformations actually, and they are the horizontal shift and the vertical shift on the SAT. So let's talk about those. The other ones are a little bit more complicated, and you'll probably get into that later in your math classes. But on the SAT, you know these two. So horizontal shift, okay, can be represented with the letter C. And if we look at the equation, it's x minus c. So if we're shifting to the right 3, you might think that right is positive. If you think on the number line, right is positive. But since it's x minus c, we just do the opposite of that. This is f of x minus 3. And for a shift left 5 units, it'll be the opposite of that. So if left is negative 5, opposite of that is just plus 5. A shift up 1 unit. This is simple because we just have the simple plus d, so we don't have to worry about any sign changes. So that's plus 1, and if we're going to shift down, that would be negative, so minus 6. So let's take a practice problem. The linear function f of x is defined as 7x plus 3, and g of x is defined as f of x shifted left 3 units and up 7 units. If g of x can be defined as g of x equals ax plus b, what is the value of b? So it's asking for the value of b. Let's use what we learned. So g of x is going to equal 7, and now let's look at the transformation. So we've shifted left 3 units. So let's do that, 7x plus 3, and then up 7 units, so that would be plus 7. Remember this equation? I'm just following that and plugging that in for x and stuff. So now let's expand this out. So g of x now equals 7x plus 21 plus 7, which equals 7x plus 28. And the value of b, ax plus b, is 28. Alright, let's talk about function notation, all of this brackets that I was writing about earlier. A function is basically just a relationship of input to output, and functions can only be one-to-one, meaning every input only has one output value. So in order to describe it, we use this notation f of x. And this means that we are plugging x for any value of the function. And you can use any letter that you want for f. It's just f is for function, so that's why we use it very often. So if you're thinking about f of g of x, it's just a more complex way to write, okay, we input a value of x for g, get an output, and then plug that output as input for f, and then figure out that output. So let's do a practice problem. So the values f of x and g of x are provided in the table below with certain x values. And the function h of x can be defined as f of 3 times g of x. What is the value of h of 2? So let's do this real quick. First thing we need to do is figure out this inside part. So g of 2, we'll just plug in the value of x. So g of 2 is equal to 3. And now we just have f of 3 times 3, which equals f of 9, which equals 6. And that's your answer. So I hope you guys learned some things about algebraic transformations as well as function notation today. If you have any questions, please feel free to drop them in the comments and we'll answer them as soon as possible. Thank you so much and good luck on the SAT.